In this video, we're going to show how you can deploy and configure as well as maintain a multi-node Kubernetes cluster using K3s on scale computing HyperCore, and we're going to do it using Ansible. All the playbooks and steps are that I'm going to go through are available on our public Git repo, scalecomputing.com. At K3s on HyperCore is the repository. You can Git clone that down to your machine and make the changes that you need and run through it just like I am here. The instructions are all in this README file, all the steps, dependencies, how to get those all installed. We're going to basically pick up at the point where we've already edited the vars.yaml file, and this is where basically you have all your site-specific customization. It'll come pre-populated, so if your IP addresses happen to work with what's in there, great. Otherwise, I changed the configuration to my local IP addressing that I'm using here. So I'm going to set up 3 control plane or server nodes. These are the IP addresses I'm going to use, and I'm going to set up 2 worker nodes. I've also got a load balancing Metal LB load balancer set up, and so a range of IP addresses that the load balancer can assign. And then also as part of this, we're going to automatically deploy an NFS file server and configure all the Kubernetes nodes to be able to access it and for containers to store their data on it. So we'll go ahead and get this started. This is the cluster we're going to deploy on. The first things that it's going to go through and make sure you have the template. It's going to configure the NFS server, deploy the rest of the VMs. Let's kick this off and we can talk through things as they go. And I'll speed up parts that do take a while. The total process here for me takes about 10 minutes to get to the point where I've got Kubernetes up and running. So in my case, I've already got the image downloaded to my Mac and as well as uploaded to the cluster. So we're doing this all based on Ubuntu 22.04, but that is something that is specified here. If you wanted to use a different cloud image, we do have plans to test it with at least with Debian. But everything here, again, as I configured, is coming out of this inventory YAML. And all the delays and waits and checks and everything that you need are all built into this. This overall playbook is also a great example of how Ansible is very powerful in the fact that you can use multiple collections, orchestrate multiple things together. So for example, even on like this NFS server, we're starting out with using the HyperCore collection, actually using this role that takes a basically an image that's already been uploaded, turns it into a VM, configures the VM using variables out of that variable file. Then once that's done and it's up and created, then it makes sure that it's up and running and booted. Then it connects in to the VM, uses HyperCore actually as the inventory. So it sets specific tags here. You can see if we look at some of the tags on this VM that allow it to basically be used, gathered as inventory by Ansible. So these are very important to get set automatically as part of the creation. But then it connects in using NFS, and then it uses a specific role that someone built to very easily, just with a couple parameters, configure NFS shares. So that's all done by default as an example. Okay, at this part of the playbook, all of the VMs have been created, and here it's basically waiting to be able to connect into via SSH all of the hosts directly. So making sure that they're far enough along in their boot process. Once it's in, it'll actually check to make sure that the cloud init is complete, and so it's got retry loops that it can sit here independently and wait and check those. All right, so we are definitely into the K3s configuration portion. Again, it's going through, in this case, configuring all the server nodes. So we've configured all these with the NFS client. This is adding the NFS provisioner for Kubernetes. This is what allows any application to be able to do a persistent volume claim, automatically have that connected to the storage on the NFS server. Okay, so now our playbook is all complete. Everything is all configured. There were no errors on this time. I have at some point seen some minor errors. And this is all designed to be idempotent, so I could run this again and correct any errors. I could also make changes up here, add additional nodes, change the version of k3s, and so forth if I wanted to. What we'll do now is, let me scoot this over here. We'll go ahead and install some applications. And these are sample applications that are part of the README file. So let's do a couple of things here. Let me make this a little larger even. Oh, wrong direction. All right, so let's first of all connect to this cluster. All right, so this is setting this new cluster as my default context. So now we'll just do a get nodes. So we can see there's my cluster. If I want to get more detail, I can do this and see the IP address, the Ubuntu version, so on and so forth. Let's do k get pods. So nothing in the default namespace. If I want to look at everything, we can see all the different, we can see metal LB, so on and so forth running here. All right, let's deploy an application. So we've already done this part here, so we're set. Where is? All right, so let's just deploy. There's this default web app that's part of this repo as a sample. We're going to go ahead and apply that. We see that it gets deployed. Now if I do a get pods, we should see that pod is deployed. Another thing that's interesting about this application is it has storage. So this actually is using storage on the web NFS server. It's also got front end exposed on port 8080. So let's go ahead and let's see what this app actually does. And it's just a simple web server that I can go ahead and browse around through things that normally in production you wouldn't want to be able to browse around through. But so there you go. So we've deployed an app, and that app also uses storage here. Let's go ahead and there's another more complicated app. We could go ahead and manipulate stuff on the server, but let's run this here. I've already cloned this repo down, so I know I don't need to do it, but I do need to go into, let me get rid of the toolbar here. I do need to go into Cube, microservice demo. All right, so now we're going to create a new namespace. We'll go ahead and do this one too. So now this is our default for anything we apply. We're going to apply this Kubernetes manifest, and this will start up all the pods that we'll see here. We can get pods. See the stuff is still creating. We'll give it a second. This does use a load balancer. So if I do a get all, in our context, we're going to see there's no storage involved in this, but there is a front end service, and it's exposed on port 217. So when our pods are all up, we'll go ahead and connect to this demo application. So I still not everything ready. I have another times prematurely connected in. It's fine. Well, you just get some errors actually, so it may either be just running or may just be lacking. Oh, it doesn't need the load generator here. So here is our application, and it's just an online shopping system. It's got a whole bunch of different services. Let's go ahead and continue shopping, add some more stuff. We'll buy a bunch of these. We'll continue shopping. We'll buy a bunch of these. All right, so we've got a bunch of stuff in our cart, 17 items, pretty price. We've got our pricing in here. Let's go ahead and place order, and we're all good. So we have used this application here. And again, I recommend everybody try this out. It's an easy way of configuring, deploying, and managing Kubernetes in production. Not everybody needs a multi-node Kubernetes cluster like this for your application. Not everyone needs persistent storage that is shared. So one thing is, if you notice, these are RWX storage. So Get a C storage class. If I look at these provide read-write many storage with the NFS, which is useful for things that, if you have applications that are load balanced and multiple pods sharing the same data, you have access there. But in many cases, you can just use this local storage and it's all fine. Some of the other things that you could see wanting to do is maybe managing node affinity, to making sure that's not part of this playbook, but that could be added. Making sure that your worker nodes are distributed across multiple physical nodes, both for load balancing, and so if something dies, things just continue to operate. Same thing with the control plane nodes. You may want to distribute your control plane, etcd nodes, and so forth across multiple Kubernetes servers that way. With that, thanks for watching.